honor for me to be able to here speaking, and thank you very much, Professor, for inviting us. And Singapore is not quite a strong history in supercomputing, and the track record has so far been patchy at the national level, but things are going to change going forward. And although we are not able to make official announcements yet, I will just give everyone a rough update of our latest progress in this regard. So, thanks very much, John. So our historical trajectory has been over the last couple of decades, when we first started out in the university, and several universities along the way have been putting up their best efforts to construct and enter into this area of supercomputing and high-performance computing. But in the last couple of years or so, we have managed to convince government to come up with some kind of national plan going forward for a tiny island like Singapore to be able to participate in the HPC arena. So the CEO of ACRC, or A-Star Computational Resource, is behind somewhere, Marek. Yeah. And Marek Mikhailovich has been leading this initiative for the last 6 years or so, I believe. And of course, he has been imported from Australia. Thank you very much to Australia. And so there has been a history of help and assistance, and we thank all our community, this community here, for assisting us to get up to speed. And we certainly look forward to more collaborations and cooperation, opportunities for cooperation with everyone in this audience. So the government has decided to fund a National Supercomputer Centre as a joint effort of the Agency for Science, Technology and Research, together with the National University of Singapore, which historically was the first organization to procure a supercomputer, and with the Nanyang Technological University, NTU, and the SUTD, Singapore University for Technology and Design. And together we have put together a proposal to finance the formation of a National Supercomputing Centre, NSCC, and to procure a 1+ petaflop supercomputer, hopefully with a recurrent technology refresh every 3 to 5 years. And we hope that the individual stakeholders, including those institutions listed up there, together with industry, will be able to cooperate in co-invest in the operational expenditure from primary and secondary stakeholders. And together with this, we also made an interesting, took an interesting lead from our Korean partners, because Korea in the last few years have their government put in place legislation to build a national supercomputing and networking institute. So we thought that it was important for us to combine HPC with high-performance networking in order to match the demands of big data. So as part of that proposal, we have included a Science, Technology and Research Network, codenamed STAR-N, and it's the provision for a high-bandwidth network to interconnect distributed login nodes from our stakeholders, as well as to provide international connectivity to where lots of data is being generated. And it could be from us participating in the SK project, or it could be with the LHC. But more importantly for us in Singapore, in the healthcare sector, the genomics repositories that are located in EMBL, as mentioned by the earlier speaker from Australia, as well as from US and including Japan, amongst the various locations where lots of genomic data is being generated. So this HPC facility will also include the high-performance network connectivity to plug Singapore into the sources of big data. So this combination of international network connectivity will be matched with the last mile problems that I think many of us have encountered. You can build a large supercomputing resource, but end users need to have that accessibility to the resource. So in that regard, we're building a national network fabric that will reach our end users. So the tender has been awarded actually, and that's public information just for your attention, that we have awarded that sum of money here, which is in tiny fine print, not yet announced with deference to our vendor partners because we are still ironing out some details. But essentially, some of the basic features of this supercomputer that we are acquiring will include these following metrics: 1+ petaflop to the minimum possible to get Singapore up to the petascale league, and we will have these kinds of features of 10+ petabytes of storage, pretty fast I/O burst rates at 500 gigabits per second, and we hope maybe through negotiation perhaps that might even increase. We hope to also have this feature of a national licensing options. We have been successful with a few, but not so successful with others. Perhaps this community here could sort of unite and cooperate with each other to lend additional weight to ensure that we are able, with software licensing schemes that are amenable to us, scaling to thousands and thousands of cores, rather than to have a linear scale in terms of paying for licensing fees. We will have a few large memory nodes, a few fat nodes here, and that will complement some of our applications amongst our user community that they have highlighted to us. So we have actually asked our user community to feedback to us what kind of infrastructure they need. We will also be experimenting with, we have been experimenting for the last couple of years on InfiniBand interconnections that extends beyond the data center, and we will, going forward, implement this as a demonstration of our findings over the last few years. So we have, because of the feedback from our end users that are not so familiar with GPUs, the use of GPU, we've only allocated 10% of nodes to be GPU accelerated. And so we expect that number to increase, but essentially that is the starting point of entry that we have decided at this point. And it will of course be warm water cooled. Now, regarding the InfiniBand fabric that I mentioned to you, many of our end users have this requirement of visualization and so forth. So our idea was not just to provide TCP/IP access, but also to build an InfiniBand fabric. Hopefully, if things go well, we hope to be able to construct a national InfiniBand fabric to reach various concentrations of researchers, research institutes, and campuses where there is a large concentration of users. So this infrastructure is currently being planned for at this point. And one example of accessibility is that with our Genome Sequencing Centre, the Genome Institute of Singapore, GIS, where we are currently experimenting with the 500 gigabit per second primary link between the sequencing center and the supercomputing data center. And finally, this is our global connectivity plan. As an anchor tenant, the National Supercomputing Centre will be an anchor tenant of, an anchor participant of the InfiniCortex project. If you visit our booth, you'll be able to see more details about our plan going forward of interconnecting US with Singapore through the Internet 2, and of course with GIANT through the 10*CC, the agency of 10*CC based in Korea, to initiate the 10 gigabit per second link from Singapore to possibly London or Amsterdam. This link here, we are planning for 100 gigabit per seconds link, probably dropping in Seattle and or possibly LA. So eventually we hope to partner with networks like Internet 2, ESNet, and GIANT network to interlink with supercomputing partners around the globe in this global infrastructure that we hope to construct by the end of this year. The tenders are in progress, so I cannot say too many things about it, just to say that it is in progress, and we hope that we can link up with supercomputers throughout the world through your organizations as represented here in this audience. With that, thank you very much. This is our latest update, and we hope to come up with official news pretty soon. Thank you.